In this video, I turn my room into a convenient workshop where I'll be repairing various tools and similar equipment. I've set a goal for myself to earn money for a set of tools that I'll need for future videos. But first, I still need to find some clients. I grab my phone and create an ad where I describe the services I offer. After all, I already have experience restoring different items. I've brought all kinds of things back to life before. Some time passes and a message from my first client appears on my smartphone. I immediately agree to help him. We get into the car and head to the meeting spot. After waiting a little while, a man walks up to me holding a bag with a tool inside. I ask about the symptoms of the problem, take the bag and get to work. So, here it is. Today in my workshop, we have a completely beaten up drill from the well-known brand Dewalt, a company everyone has definitely heard of. Dewalt and reliability are practically synonyms, but as the client explained, it suddenly stopped turning on and showed absolutely no signs of life. What's surprising is that this drill worked for almost 20 years, but we'll do our best to make sure it lasts even longer. After plugging the drill into the outlet and pulling the trigger, we saw and heard absolutely nothing. Not even the slightest hint that it was working. What immediately caught my attention was the electrical tape on the power cord. If the cable is broken somewhere, that could easily be the cause of the failure. Cutting the tape with a knife, I did notice a damaged wire inside. However, nothing looked critical, and in theory, the power should still be reaching the tool. Of course, we're not going to leave exposed wires like that. Let's add some blue electrical tape.
It's unlikely to help.
Although I doubt this will help. Without a full teardown, we won't figure anything out. So we grab a screwdriver and start removing the screws. About a minute later, the drill was opened up, and what I saw inside honestly shocked me. The interior was incredibly dirty. On the electronics, I noticed metal shavings, piles of dust, and even a small stone, which apparently broke the cooling fan. The gearbox components weren't sitting in grease anymore. Instead, they were covered in some brown substance that definitely no longer had proper lubricating properties. We take a can of compressed air and lightly blow out the inside of the drill. Everything is so dirty that I don't even want to touch it with my hands yet. Carefully removing the electronic section of the tool, we set it aside while the mechanical part can wait. First, it's worth checking the carbon brushes. That's the most common problem in tools like this. Ours showed uneven wear, so we removed them. Next, we disassemble the motor and take out this component so everything can be inspected. There was some slight carbon buildup on the part, which could also interfere with proper operation. To check whether it's working correctly, we'll need a multimeter. We switch it to resistance measurement mode and place the probes on the component. The device should show roughly equal readings, which is exactly what we saw in our case. Next, we switch the multimeter to another mode and checked whether there was any short circuit to the housing. Everything looked good here as well.
This part is definitely working.
After that, we took a closer look at this part to check for defects. Using a magnifying glass, we could see that the entire winding was intact and everything here looked perfect. That was definitely good news. At this point, I think the problem is most likely the brushes, but it's possible the trigger switch will also need repair. So we head out to look for the necessary spare parts. In a store that sells and repairs tools, we bought some similar brushes, and that pretty much concluded our shopping trip. In the next store, we planned to buy a replacement cooling fan, but they told us that part was no longer available. Then we drove to a service center. At the gate, there was a sign with the brand of our tool, which gave us hope, but unfortunately, we were disappointed there as well. After visiting another dozen stores, we still couldn't find the parts we needed. At least we managed to buy a new power cable at the market. Calling this shopping trip successful would be a stretch, but we'll work with what we have. The brushes we bought won't fit in place without modification. They're slightly different. So we grab a rotary tool with this attachment and cut small grooves into these parts of the brushes, just like the original ones have. We try to do everything carefully so we don't grind away too much and ruin the part. The result looks quite similar, but the new brushes also have a different type of connector. Using wire cutters, we clip off the springs with the contacts, leaving a little bit of wire sticking out. To that wire, we solder a short lead, an inductance coil, and another wire. All All the exposed sections are covered with heat shrink tubing, and in the end we get a replica of the original brushes. Now we just have to make a second one. The new brushes are ready. Before reassembling the motor, it's very important to clean the armature from carbon buildup and dirt. For this, we'll use contact cleaner, a product designed specifically for this purpose. We apply a small amount onto a cotton swab and carefully clean each commutator segment. The part begins to shine again. Now we assemble everything back together and install the new brushes, making sure to secure them with the pressure springs. All the wiring gets connected back to the trigger switch, including the power cable. We place the internal components back under the housing cover and secure it with 2 screws. That will be enough for a quick test. Plugging the drill into the outlet, I pull the trigger. We immediately hear a strange sound. The light flickers, the drill doesn't start, and smoke begins to come out. We quickly disconnect the power so nothing burns out. Looking inside again, we see a burnt wire. At this point, we decide not to take any risks and instead replace the entire internal wiring with new wires. I disconnect the old wires one by one and connect new ones in their place so the original circuit layout stays exactly the same. Even though our power cable still works, we'll install the new one anyway. We place all the electronics back into the housing, reassemble the tool, and prepare for another test. Honestly, I'm a little nervous this time, but as soon as I pull the trigger, the drill comes to life, and what a sound it makes! The motor runs incredibly smoothly, almost like it's brand new. The trigger works perfectly, and even the reverse function operates flawlessly.
We fixed the problem.
At this stage, we could already return the tool to the client, collect the payment, and forget this drill like a bad dream. But I can't do that. A good craftsman's tool should also look good. Looking at the drill chuck, we can see rust, while the plastic housing is heavily stained and the stickers are worn out. So we disassemble the tool again until only the housing remains. Now we're going to work on restoring it. The plastic parts go into a container and we take brake cleaner and apply it to the housing. This product does a great job removing old grease and other contaminants. We also use a brush to clean dirt even from the smallest gaps and cavities. The inside of the housing is now completely clean. On the outside, we can see hardened cement. Apparently the owner works in construction. We scrape it off with a scraper. The old stickers won't come off easily, so we heat them up with a heat gun and then peel them off almost effortlessly. Next, the housing needs to be properly sanded. From experience, the most convenient way to do this is with sanding sponges. We lightly moisten the plastic with water so the abrasive slides more easily and doesn't clog up. We start with coarse grit and gradually move to finer ones until all the ugly stains, cloudiness, and surface imperfections disappear. The most important thing is not to accidentally sand off the manufacturing markings with the production year, because this drill is actually something of a vintage piece. Eventually, the sanding process comes to an end. After finishing, the housing already looks much better. The color is now uniform, the stains are gone, but unfortunately, not every uneven area could be removed. If you focus the sandpaper on one spot for too long, you can actually damage the surface even more, but that can still be fixed. We take plastic filler and polyester resin. The filler goes into a container. Then we add a little resin and a larger than usual amount of hardener so that the liquid mixture will definitely cure. After mixing the components together, we get a thin repair compound suitable for delicate work. Using a brush, we apply it to all deep scratches, chips, and other imperfections.
20 minutes later.
Once the filler hardens on the repaired areas, it's time for sanding again. Using sandpaper, we carefully level the raised filler until the surface becomes smooth. We go over every repaired area with abrasives of different grits. As you can see, all the deformations are now filled, and after painting none of this will be visible. And that brings us to the next stage, painting. But first, the plastic needs to be wiped thoroughly with a cloth soaked in anti-silicone cleaner to remove any grease marks. After that, we hang the housing parts and begin painting. First, we apply plastic primer. This is the base layer that all the paint will adhere to. 2 even coats are applied with a 20-minute pause between them. After the primer, we apply a durable paint. We chose a color that matches the original as closely as possible, and it turns out we made the right choice. During the painting process, we didn't even notice the color changing. It simply became evenly coated. To protect the finish, we also apply a strong clear coat. Tools constantly experience physical wear, so ordinary paint would quickly chip off. The housing dries, and after painting, it's completely transformed. The color matches the original, the plastic shines slightly, the surface imperfections are hidden, and most importantly, all the important markings were preserved. The result looks fantastic, but before putting the internal components back into the housing, we still need to fix a few technical issues. The bearing started making noise just as we suspected. The old grease is no longer doing its job. We bought new ones. They're inexpensive, and we also picked up a special bearing puller. With it, removing the old bearings is very convenient. Before installing the new bearings, we apply a bit of grease to the mounting seat to make installation easier. Then, using a small wooden block and gentle taps from a hammer, we press the bearing into place. We repeat this for each one. The drill chuck is still fully functional, but it looks terrible. I cleaned it slightly with a rotary tool and a wire brush attachment. Then treated it with a bluing solution to protect it from future corrosion. There is one final problem left, the broken cooling fan. As you remember, we couldn't find a replacement, but we did have some large zip ties that will help with this repair. We heat a piece of the zip tie with a lighter, and while the plastic is hot, we press it against the location of the broken blade. Using a heated scalpel, we smooth out the joint and cut off the excess with wire cutters. We repeat this process for each blade. The result looks surprisingly similar to the original, but the most important thing is that the drill will now cool properly, and all of this will be hidden inside the housing anyway. Now it's finally time to place all the electronics back into the housing. Before closing it, we apply fresh grease to every part of the gearbox. I applied a generous layer to all the moving components. We close the housing. The old screws were not reused. Instead, we install new ones and tighten everything carefully. All that remains is to attach the stickers.
You actually believed it?
We digitized the original ones and restored them using artificial intelligence, then printed them and placed them back in their original positions. I honestly can't believe my eyes. This drill is completely unrecognizable. It looks like I just took it straight out of the box, especially when you remember the condition it arrived in. But will it perform like a new drill? Let's find out. And at the same time, test it before returning it to the client. We have 3 levels of difficulty here: wood, concrete, and metal. Let's see if this old Dewalt can handle them all. We insert a drill bit into the chuck and start drilling. The drill goes through wood perfectly, creating a hole in just a few seconds. Concrete is a bit more challenging, but the motor still has more than enough power to do the job. The thick-walled metal profile was drilled easily without the tool even heating up. And if you replace the drill bit with a driver bit, this drill can also drive screws with ease. It handles them effortlessly. This turned out to be an excellent tool. We calculated all the expenses. Many materials we already had, so we didn't need to buy them. The entire restoration cost about $20. Honestly, I don't want to part with this drill anymore, but it's time to meet the client and return it. Even before seeing the result, the client was already happy. But when he took the tool out of the bag, he froze in place because he thought we had replaced his drill with a brand new one. The client was extremely satisfied, and as a token of gratitude for the repair, he gave me $50. Considering the expenses, the net profit is $30. That's a great start. The money goes into the savings jar, and now I'll be waiting for the next order. You leave a like, subscribe, and drop a comment below, and I'll bring you the next episode of this series.